formal presentation. There won't be any formal presentation because, all these breeding methods and this and that, it's already given in several textbooks and you have already studied these in your undergraduate, postgraduate programs. So I won't be repeating on that, but I would be highlighting, few of the events which I learned outside the textbooks during my career with groundnut. And some of these things you won't find listed in any textbook. This is by experience and by close observation in the field that you come to know, and then they help you in your future efforts. So I'll make few opening observations, and then please feel free to stop me and raise any point or any issue that you want to raise, or if you want to ask any question. As I said, this is interactive, so just be more active and don't fall asleep while listening to the lecture. Now, in any breeding program, I think clarity of the objectives and clarity of the targets, these are very important. And you would laugh if you go past 40 years or 50 years, look at the breeding objectives of the breeding program in India. They are same. They have hardly changed. Except that some tools have changed, new tools have come in, but the objectives, they remain the same. Breeding for leaf spot resistance, breeding for high yield, breeding for seed dormancy, like that, blah, blah, blah. It's like it. So this is just a very casual statement. One has to, okay, if you want breeding for resistance to leaf spot, what is the present level of resistance that you have? And what is the next level that you want to achieve? There has to be clarity on these points. Unfortunately, there is no such clarity. So please make sure your breeding objectives are very clear and the target is there. In next 3 years, you want to, let's say, if you say breeding for high yield, today we have, let's say, whatever yield level we want to say to 2 ton per hectare, then we should fix the target, In next 5 years, we want to improve the yield by 5% or 10%. And then we should plan our strategy depending upon the objectives and the targets. Unfortunately, I find this missing, or not missing, let me use the word blurred. Clarity is not there. That is what is required. Do you agree with my observation, or you have a different view? Anybody is welcome to respond. Are you able to listen to me? Am I audible?
Yes, sir. Audible, sir.
My friends, it has to be interactive. It is not going to be monologue. Silence means either you, you are also not sure what objectives you have, what is the target you have in your breeding program. Nobody wants to make any comment?
Yes, sir. We have sure in our breeding objective and target, sir. Good morning, sir.
Good morning, Singh. No, but as I said, okay, take any objective that you have. What is, just tell me one objective.
For yielding, sir.
So how much yield improvement you want in next 5 years?
Approximately 10 to 15% yield.
Right. So have you specified that in your objectives?
Yeah,
No, there
sir.
is no specification. There is no mention of targets, and that leads to the accountability issue. Eventually, just a generalized statement bidding for high yield, that gives a general statement, and everything is covered. Even if you are raising your yield by 1%, oh, I have improved it by 1%. So anyway, important
Yes.
thing, as I said, is clarity of the objectives and the target that you want to fix for each objective, and what is your roadmap to achieve that objective. These things are important, and think they require a lot of planning. It's important to spend more time and focus time on planning. Once your planning is done, then a lot of things fall in place and everything becomes easy. If we know what are our targets and what are other issues involved in the crop that we are talking about, then next step is, okay, if we want to have we will debate whether we want to have breeding solution for each and every problem, or we can also look for management solution. I'll give you one example. Iron chlorosis. Iron chlorosis, again, it's a inherited trait. One can find resistant sources. One can probably breed for it also, but it's not widespread in certain pockets, in certain kind of soils. It may become a problem, but otherwise not a serious issue. So if we start a breeding program on this, whereas we have a simple solution for that, make iron spray, ferrous sulfate spray. If you give one spray, two sprays, which also will have urea will mix into that, that gives you an easy solution, and also benefit of other nutrients such as urea, as I said, and sulfur. So one has to divide, one not looking for every solution through breeding. Management is also an important aspect, and we should exploit, as we exploit genes, we should also exploit management options, so that, whatever is economic, whatever is easy, because anything that you do, when it comes to resistance breeding, resistance doesn't come free. There is always some cost involved in resistance. Up to a point, yield and resistance can travel together. But a point comes, then resistance starts asking sacrifice from yield, price from yield. So, genetic solution and management solution, same thing applies there. So make sure you know what is economic and what is easy to follow. Go for it. Being breeder doesn't mean that everything you should devise is by exploiting the genes. No. Management that is extra genetics, and they should also come in our equation. and this should also come in our strategy and planning. Once having decided upon the objective and being clear what we want, next step for any breeding program is to select parental material. So how would you go about the selection of parents? Can someone elaborate on that? I'll just call name myself from the screen what I have because nobody is speaking. Okay, Dr. Vijay Dalvi.
हेलो सर या गुड मॉर्निंग
Good morning. बोलिए
या
साहब ये how would you select the parents for your breeding program?
एक्चुअली our is the sir volunteer center we are testing only
Okay.
yeah
So
yeah
there's no active breeding program.
no no active breeding program sir.
Okay, good. No
uh,
problem.
yeah
Uh, where is Narendra? Narendra is not there?
He's not joined it.
That's funny. Sahil Patel is a scientist or a research assistant?
Research assistant, sir.
Reddy Saab, Parmeshwara, no, Maheshwara Reddy Saab.
Sir, good morning, sir.
Good morning. Yara, you tell others how one should go about selecting parents for a
Sir,
breeding program.
I am agronomist, sir. Anyhow, I will respond to your query, sir, because no
Okay,
problem, sir. Whatever the experience that I am having, and by seeing that Vasanthi Madam and all, I learned from Vasanthi Madam, sir. I am from Tirupati.
okay.
Madam, we have to interact based on our problem now, sir. Here, if the seed dormancy is problem, leaf spot is problem, whatever the problem in our area where we are working in our southern zone, based on the farmers' problem, we are deciding that which has to be taken as a male and female parents, sir. Based on that, resistant lines from the particular trait and character now, sir. Based on that, parents will be selected, sir. Because in tag 24 also, because short duration was the problem. In Nellore area, they grow very lot in extensive areas of tag 24. But there is the fresh dormancy is the problem, and also with respect to the duration also, sir. Short duration, and for that we select the parental line with having the short duration and having that fresh dormancy, like that we are targeting, sir.
Yeah. Right, okay. If anybody is starting a fresh breeding program, depending upon the objective of your breeding activity, I would suggest first one should do the search in literature for that particular trait. What has happened at elsewhere? What has been the experience of other? How did they succeed or why did they fail? Once you do the literature search, you would be able to shortlist several parents from there, which will become your source material once you have prepared a list based on the review of literature. Then analyze each parent, how it has performed. Did it do well only at one location, or many breeders used one particular parent and were successful in developing varieties? So like that, analysis is required so that you can narrow down on the parent that you would like to use for a particular objective in your breeding program. Another important aspect is if it is about disease resistance or pest resistance, one has to be very careful from literature. If somebody has reported variety X is resistant and then you believe that and you bring it in your breeding program and do start using it without verifying, you may end into disappointment. Whatever you read elsewhere, whatever you get report from elsewhere, you need to bring in that material and evaluate at your own location. And you have to be 100% sure if it is a resistance breeding parent, whether it is really resistant and why it is resistant, what are the factors contributing to its resistance. And then different parent would have different factors contributing towards resistance. And there also you can complement different resistant parents by bringing in different factors into the background, common background. So verification at your own location is important for whatever trait it is. Resistance example I gave because it's very clear. Another thing, let's see, if you take one variety, say TMB2, and take one lot of TMB2 and divide it to 10, 12 lots and supply them to different locations. And these lots are then maintained at those locations over a period of time. You will find big differences between these lots, although they all came from one source. Since they are being evaluated in different environments for a long period of time, there is genetic shift is there, depending upon the local environment and other local growing condition. They really become different. Although in our records, we will always say TMB2 everywhere. But the TMB2 at Ludhiana may not be the same TMB2 at Junagadh. So if somebody has reported from Ludhiana that TMB2 is very resistant, and so the Junagadh person starts using TMB2, what they have got, it may be completely misleading. So that's why I said verification at your location is essential and you should definitely do it. Another aspect which you will not find mentioned in textbooks, latitude and longitude. If suppose my location is at 40° north for latitude, see what are the countries at 40° south who are growing groundnut and what are the varieties they are growing. Try to get varieties from there and evaluate them at your location. Chances are that you will find some good material coming opposite latitude. Same thing applies to longitude, east and west. And this way, you are able to bring in the genes which are more pre-adapted to a situation, to your situation. Another thing, any material that you are bringing in, the first year performance is not the best criteria to select or reject something. minimum 2 years evaluation is required, because first year, as I said, there is always, I cannot explain it, but it is there. The performance in first year and the performance in second year of the same variety, irrespective of the fact that season would be different, but they are very, very different. And there is no explanation for that, except maybe some kind of fine tuning in genome. Some genes which were inactive, they become active in second year after being grown for 1 year in particular environment. But it does happen. So just based on first year evaluation, don't throw away anything. Give it one more chance before you reject anything or select anything. So I'll stop here now. I'll ask comments from the listeners, they what comments they have got to make. Doesn't have to be any breeder. Like Reddy Saab, although being an agronomist, he made comments. So please, now, so far, what I have talked about, I have got a lot of points. If you remain active, then I'll discuss each and every point in detail with you and share my experience. But if you are a passive partner, then I'll cut short it and then close the session early. So now on these points, again I invite comments: breeding to objective, breeding charges, selection of parents.
Sir, most of the times there is a lot of difference between the breeder seal and farmer seal, sir. Whatever while releasing the variety, the yield may be very high, but when it comes from the farmer's point of view, that seems to be, because what you told in the first year and second year, that depends upon the environment and also season also, but there is a lot of difference sometimes with what we see, sir.
No, that is true. I think we will come to that in the end. Right now, we are confining our discussion to breeding program at the station. The important point, what you said, is very much right. And how to overcome that, I'll come to that when we travel little more into the process of how to initiate a breeding program and how to move forward step by step. So definitely we will talk about that.
Okay, thank you.
Sir, I have one question regarding
Yes,
selection of resistance parents.
yes.
For example, for some of the traits like stem rot or this one, ELS or LLS, rust also, we have
Yeah.
several sources. So which one to select? Like, are the already released varieties or just the germplasm that was identified as resistance here? Because the compatibility issues will be there again, and so how to go ahead with that? Sir?
Yeah, okay, just a minute. Actually, if we talk of, let's take for example, late leaf spot and rust. There are more than 250 sources of resistance reported in literature, maybe more now. When I was active, then at least 250 or so. Now, which one to use? Now, obviously, you cannot use all of them, but I'll do 2 or 3 things. One is I'll again look into the literature on disease resistance breeding and see what others have used, what parental sources they have used in their breeding program. And the resistant varieties, I'll do the survey of resistant varieties and their pedigree. Find out what is the source which is occurring more frequently than others. So that will help you to narrow down. Then third thing is, we will encourage our pathologists to study these 250 sources of resistance and find out what are the factors contributing towards resistance. It is longer incubation period, or it is a whatever other factors could be there. Long Hari would be able to tell you different factors, So we need to have complementary factors. And then identify those parents and you can bring them together to improve the level of resistance by bringing in these factors which are giving or contributing towards resistance. So that is one thing. Second thing is released varieties also you can include and study them. Released varieties, if they are giving you good level of resistance or the level of resistance that you want, then you can use those also. But in this case, you would be interested not only in resistance, but also your yield, whatever mechanisms are there to make use of those into your breeding program. Sometimes you may be disappointed that high yielding resistant varieties, though themselves are good, but they may not make good parents. They may not give you good segregants. So their breeding value is important. And now lot of techniques are available to study, but in a applied breeding program, you cannot study all this. And this is where you should make use of your students. They should carry out these studies for their MSc, PhD thesis. And that information emanating from such research then can be utilized in a breeding program, applied breeding program. Does it help?
Yes, sir. Yes, sir. Sir, actually, I'm screening Spodoptera, many core germplasm for Spodoptera resistance.
Yes.
And so far, not come across any promising germplasm for resistance. And also tried some testing, some screening, some this one wild accessions also.
Yes.
They are showing good resistance, but some of the characters like the hairiness, leathery texture of leaf, or wax content is more, but they are not accepted by this one as a farmer. So how to use them as parents, like the wild accessions?
Okay, I'll tell you first my own experience, which was really very devastating as well as very I learned a lot. This Spodoptera thing. One Friday afternoon, I was taking round of my fields and everything was fine. There was no issue at all. And then Saturday, we don't work on Saturdays and Sundays. But it's pathogens, they are active 365 days, 24 hours, no problem. So Monday when we came back, the whole field was gone by Spodoptera damage. They have chewed all the leaves, but there was one genotype which was still standing here and there, wherever that was row was there. That was, if I remember the number, North Carolina accession 17090. And but after one more day, that accession also went down. So in a situation of choice or no choice, If it is a choice situation, you would be able to find, I won't call it resistance, but preferred and non-preferred host. You can't find resistance for Spodoptera. Either they have to eat the leaf or they have to die. They die because of starvation, or they die after eating the leaf, which has got some anti factor and then harming those insects. So that kind of situation is there. Now, wild species you find, first important thing would be to know what is the factor they are contributing for their resistance. If it is hairiness, of course, you can do some devised experiment by removing the hairs, which can be done. There are techniques available, and see those species, wild species, they remain resistant still. Then there is some antibiotic factors involved there. If it is just because hairs, then if the hairs get diluted in breeding program, then obviously the resistance will disappear. So what you are looking for, antibiosis, and if that is the factor for resistance in wild species, then chances of succeeding are there. But one has to keep in mind when you are using wild species, the end product, after taste of end product. And we had some very good rust and leaf spot resistant lines, but their aftertaste was bitter. There was nothing wrong with yield, resistance, oil content, but the grain when you eat it, it will leave some bitter taste in your mouth. Even the groundnut cake from these coming. So these varieties were not liked by the farmers in India, and also I remember in Haiti, in spite of their very high yield, very high level of resistance, they had to be rejected, or they were rejected by the farmers because of this thing. So that caution you have to keep in mind while utilizing wild species. They should not carry any anti-nutritional factor.
Right.
Any more comment and observation?
Sir, good morning, sir.
Good morning.
Sir, myself, Dr. Harish Babu from Hiriyur Karnataka Center, sir, groundnut breeder.
Yeah.
And I have small clarification regarding storage pests breeding, sir, resistance breeding, storage pests.
Storage.
Yes, sir, yes, sir. Groundnut, especially seed rate is high, and if proper storage is not there, storage pest problem is there. So whatever the seed we store, that will get damaged, sir. So regarding this aspect, not much work has been done in groundnut, sir, especially as per the literature survey I made.
Yeah.
Any important work has been done in this area, sir, storage pest resistance.
There was some work was done at ICAR-IIGR long ago.
Okay, sir, but in recent times, no objective, breeding objective.
Recent times, no, not in my knowledge.
Yes,
But
sir.
at that time,
Yes,
Dr. Whiteman was there, Dr. Amin. There were entomologists. Later on, Dr. Rangarao came in. But I think it was Amin and Whiteman. They did some work at that time. But again, what is that which gives resistance to storage pest?
So the resistance sources are also not clearly spelled out.
No. My question is, are you aware What
sir.
are the factors which contribute to resistance to storage pests?
Maybe the shell thickness and components of shells, the biochemical components of the groundnut shell matters.
Uh-huh.
So
So
we
if
found
the
one, in addition to that, we found one character like the reticulation, if it is less on the pod surface, sir, the bruchid egg laying is less. That's what we observed in our studies.
Yeah.
Reticulation.
pod reticulation, again, pod thickness also matters, and components of maybe the chemical composition of the pod. This was a pod shell also matters, I think.
Yeah. Okay. Now
I mean,
let's take these two characters only for the time being.
yes,
Shell thickness. Okay, we can probably make the shell very hard, very thick. What are the consequences of that?
there will be an issue in the processing, sir. The shelling.
No.
Yes, sir.
Insect is okay. You will make it difficult for insect. But what is the consequences for the farmer?
You have to strike a balance there.
So if you have too thick shell,
Yes,
then your shelling percentage will go down. And then when you are shelling it to take out the seed, then you have to put in more effort, more energy.
yes, sir.
So how are you going to reconcile this? Now, reticulation is one point where, okay, egg laying may be one factor, so the eggs are not sticking and they are falling off the pod. But in the storage, all these pods are stable, they are not shaking and moving around. Once
Yes,
they are on the floor, if eggs are laid, there's no shaking or moving. So the egg
yes,
would stay there, they will not fall off.
yes,
And if reticulation was the significant, it may be a factor, it is not a significant factor. Otherwise, your Valencia types,
yes,
Valencia type have got a smooth pod. They should be tolerant to storage insect pests. Dr. Nataraj, did you observe anything with the Valencia?
So we observed in Girnar 2, less glean. Valencia types I'm not recalling, but we have done, sir, I think. I will check again.
Valencia types, there are many Valencia types which are very smooth.
Okay, sir. I'll verify, sir. I'll verify and get.
Yeah, try and use them. But again, problem is, even if one egg is develops and the insect goes inside the pod, it is enough to kill that pod, to spoil that pod.
yes, sir.
When we have solution like uh, fumigation and all that, why should we not promote that? You will waste your time, many years, and it may happen that you don't end up with anything worthwhile. So if easy solutions are available, they should be promoted, and if there is issue with or problem with them, then that is where the research should be encouraged. Entomologists should be encouraged to carry out more research, or the chemist should be encouraged to find out new molecules which will be less harmful. Should we move forward now?
Yes, sir. Yes, sir.
So I would not do this breeding for storage pest resistance. There are many more, unless these new techniques, new tools have come up, if they can help you then it is a different matter. Otherwise, I don't think I would invest my money on this particular problem. Even storage bags are there. Hurry.
Yes, sir. Actually, yeah, hermetic storage is working very well, sir, for especially brew kits. There is no need to invest in breeding for resistance.
No, that's what I said,
Yeah,
We should not look for breeding solution for everything.
for everything. Yes, sir.
Wherever management can help, we should refine the management, make it more efficient, invest money in management research rather than, going into breeding and trying to find solution for everything there.
Yes, sir.
Yes,
For
sir.
storage-based breeding, so far, I think I haven't seen any success stories, sir, in the world.
Right, you are right. There are two things that I give them very high priority in breeding. One was the right selection of parents. And one has to spend a lot of time on that. And if you get the right parent, then you have now collected the right tools, right weapons to do the fighting. But if your weapon is not right, how are you going to win the war? So selecting the right parent, is the first weapon that you have to do. Second comes now making the crosses. Again, study the parents and based on that decide on the combination. Again, it should not be blindfolded, oh, this variety is high yielding, to make the cross with this one, that one. No. Why should you use a high yielding variety? Or why not a low yielding variety? You should know what are the factors in different parents and different varieties and how you complement. What genes are doing? Genes are, when you are making crosses, you are reshuffling genes. You are complementing them. So that is what is important. Selection of parents and knowing your parents fully well. Like nowadays they have in bank and other places KYC, knowing your customer. So same thing, knowing your parents selected for breeding program. Next step is your hybridization. And hybridization, I still find many places, very, very poor success. And there is no reason why you should not get a very high success. We used to get 70-80% success in a normal way. And if we really paid much attention, like screen house and other facilities, then we could go up to 90%. And most of the places we find that success in national program in hybridization is 10%, 20%, like that. And half of that is also mistaken hybrids. And there's the key factors in hybridization and having good success of hybridization is time of pollination and high humidity at the time of pollination. And these can be created very easily without too much of effort and too much of investment. Of course, important thing is when emasculation is being done, then there should not be any damage to stigma, style, and others. So if emasculation is done without any damage, without any injury, then these two factors become very important. At the time of sunrise, the pollination should start. That's the time when flower will start opening. Depending upon the timing, in summer season, it can be 6 o'clock in the morning. In the winter season, it may be late, maybe 8 o'clock, even 9 o'clock, depending upon the temperature. Temperature past 2-3 days, not the temperature of that particular day, but the temperature of past 2-3 days. So the key factor is at the time of sunrise. That's when flower opening. That's when the that is where the pollens are very active and 100% viability is there. And if there is high humidity in the environment, then pollen are sure to germinate and fertilize the stigma and give you the hybrid seed. Now, you can create high humidity by irrigating your plant the previous evening. So in the morning when you come, soil is wet, humidity is high. Or if you are doing it in glass house or screen house, you can use humidifiers to create humidity, high humidity for next 2-3 hours in the screen house and ensure that you get very high success rate. So it's very important to have high success rate. Second step after hybridization is to confirm the hybridity of the seed that you harvest, whether it's a hybrid seed or not. If you have done, how do you do that? You grow your F1 and you also grow your parents by the side of that F1 and compare and look for traits. Wherever you are in doubt, put a question mark, advance that progeny to F2 and see if segregation is there or not. If there is no segregation, reject the whole thing. So, in the genuine hybrids, these are the ones to be promoted, advanced further. And if you are not careful in this, if by mistake you are 10 to 20% you are advancing the self, then you are wasting your time and effort, your energy as well. So after spending a lot of time in your planning and selection of parents and analyzing, deciding on the combinations, then making the crosses, spend time in the field to make sure that your F1s are genuine F1s. If you have done this, half the battle is already won. Rest of the things, you cannot do anything. The genes will now reshuffle themselves, come together, and you will see how they perform. That's where you cannot do anything. But before that, which one to bring together so that the reshuffling is more effective, that is where you can, up to that point, you can interfere. Rest is left to the gene. So F1 has to be genuine, and then you can advance it to next generation. Now, what is often people say, what is the size, F2 population size? What is the optimum? Of course, theoretically, as much as you can, and one can even use statistics and probability, how to recover one particular combination, what size of population is required. So that's all theoretical. In my breeding program, I have never cared how much F2 population if the population in F2 was small, I'll not make any selection there. I'll advance it to F3 generation or even F4 generation. When the numbers become large enough, then I'll practice the selection. And in any case, I never practice selection in F2, F3. Only in F4 generation, I'll practice the selection. Reason being, you can practice selection for qualitative trait in early generation because the heritability is very high there and your selection would be successful. But for quantitative traits, where the heritability is low, if you practice selection in F2, F3, you may succeed, you may not succeed. But if you delay your selection up to F4, your chances of success are enhanced. Again, I'll stop here and ask for comments and observations from the Mutagi Saab. What is your experience?
Yes, sir. I agree with you. And we followed your principle to develop and breed for GPBD4 with our group, sir. So I'm listening to all the constraints expressed by the breeder, entomologist, and pathologist, sir.
Yeah.
So that we have used the second and third cycle of interspecific derivatives to put into the background resistance into KRG1, sir. So that was a one successful story. So that GPBD4. So like that, many such varieties can be developed with the multiple resistance also. Now the tools are available, the molecular and other. We can make use of those platforms, sir. AGB and those platforms.
Right.
So very practical implications. You are giving the tips to the young breeders. So we are enjoying and we are making use further. The practical plant breeding by you, that is very much useful, sir.
No, that was the idea. I said, I won't give formal lecture,
Yeah, that's
selection,
true,
pedigree selection, this and that, Important thing, what happens in the field,
Yes,
There is no substitute to field visit.
correct, sir.
A breeder, unless he or she spends 3 to 4 hours out in the field, observing each and every plant in trial and nursery, success is not going to come by easily. It requires sacrifice, and this is one sacrifice. Even otherwise, groundnut is in literature you will find, it's a very unsocial crop.
Correct, sir.
And in case of US, the pollination emasculation time was 5-6 in the evening.
Yeah, sir.
So your evenings are spent in emasculating. Then morning you come back 6 o'clock for pollination. So there is hardly any social life left.
Yeah, sir.
So
That's true.
they will call it, they call it unsocial crop.
Correct, sir.
And
even breeders also, we should also make use by using your tips, sir, at Dharwad. So continuously all 3-4 breeders, more than 80% of the success of F1 hybrid we achieved. And as you indicate, sir, the 2 or 3 season confirmation, it is an unpredictable legume. That is a very practical.
Right.
Yes. And seed multiplication, proper some mutation and T elements activation, those are also playing at background. We should be aware of those things, sir. Thank you for your persuasion and supporting us, sir.
No, you are welcome anytime. Yes. Anybody else would like to share the experience? Senior breeders like Dr. Mutagi, he shared his experience. Anybody else? Dr. Satya from Tindivanam.
He is also agronomist, sir.
Okay. So who are the breeders, other breeders? Dr. Suma Mugali?
So right now I'm working at Dharwad, sir. Just 3 months ago I have joined, sir.
Okay.
Actually, I feel introgressing traits instead of involving just two parents. If we are able to integrate traits from multiple parents, we can realize genetic gain sooner. I feel, sir. Am I right, sir?
No. Have you done some review of literature before making your point?
Actually, in pulses, we have some reviews, sir. We used to practice this.
Uh-huh.
So I thought since legume, I think we can practice here also. I thought extrapolate that this thing here also. I thought so.
Okay, I'll tell you now, since it's
Yes,
also
yes,
important point that I
yes.
wanted to discuss, like single cross versus three-way cross, double cross, convergent cross, and what they call now is magic population, this and that. Now, the literature is full of information in favor and in opposition as well in any one of them. There would be publications where you find single cross is as effective as three-way cross or four-way cross. Important thing is now why we are bringing in more parents in the early stages of crossing. Single cross by parental mating, okay. Three-way cross. Now we need to have sufficient number. If you are up to three-way is okay, because three-way you are using F1. F1 is uniform. And then you are crossing those with a single parent. Four-way also you are crossing two F1s. Again, those are in a uniform state. But if you talk of convergent breeding, crossing and others, there you are bringing in lot of parents together one by one. And a compromise of that one is the selective diallel selective mating, But the important thing is here, I'll tell you my experience. I did not find any difference between single cross, three-way cross, or double cross. And most of my program was based on single cross only. Most of. I wanted to find a replacement of TMV2 for Anantapur. And my aim was just put one more pod on the TMV2 plant in Anantapur. If I was successful in doing that, that would have meant 300,000 pots, because that's the optimum plant population. So each plant one pot, so many pots, and tremendous jump in yield. But I did not succeed in doing that. I used all the varieties which we are supposed to be doing well in Tirupati area and all that. Convergent crossing program. Problem was you are not able to capture the variability. Up to double cross level you are okay. But after that, if you start adding more parents, then you just lose. You lose the control over the variability that you are creating. So my experience has not been successful with convergent breeding. And I still prefer single cross breeding. Okay, I may go for back cross breeding depending upon the trait. These are trait specific, back cross breeding and the, but pedigree and instead of recurrent selection or convergent crossing, I would recycle the advanced breeding lines. I make crosses
Okay.
and take their progenies to, let's say, F5, F6 label, then recycle them again in the crossing probe. So you can say delayed recurrent selection. I found these kind of approaches more successful rather than textbook approaches.
Yeah, thank you, sir. Maybe it's a tetraploid, and I think it's wiser, as you said, from your experience, it's wiser to cross amongst the advanced line than the early segregating generations.
Now, can you see it? Come back again.
So unlike in pulses, which most of them are diploids, here it's a tetraploid. No, sir. I think it's your experience. I think it's correct, sir, because it's wiser to cross amongst the advanced breeding lines wherein the characters are already fixed. So it's wiser to cross amongst the advanced breeding lines than involve many more parents at the early generations, right, sir?
Right.
Okay.
Dr. Vasanti, I'd like you to comment on this. You have been a very successful groundnut breeder. Dr. Vasanti?
Sir, namaste, sir.
Namaste.
Sir,
I
I also prefer only single crosses, sir. That with my experience, if you involve more parents, we can't actually see the traits also, which trait is coming from which parent, and we may not be able to properly select, sir, actually. And I have seen some populations sent from ICAR site also, involving many TMV2, JL24 like that. Many parents may not be that easy, sir, to select in early generations or in later generations. Whatever the points that you are making, sir, they're really practical points that I have seen. I have seen you more closely than anyone else, I feel, in the group. I have that liberty to say that. And all the points that you have made, sir, with experience, with each and every word that you have spoken, yes, it is actually you have to. We are lucky, sir, to hear from mentors like.
No, I want you to share your experience with these young people like
Advanced
Suma.
bidding lane, sir.
I was happy with Suma, she
Yes,
raised the
sir.
question and discussed, that's
Yes,
what
sir.
I want the young breeders, to come up and discuss
sir.
and ask question, even if they are not sure whether it's the right question, they should still ask us and we'll try to enlighten them as much as we know. What we
Advanced
can.
breeding lines, definitely we can use if there have some contrasting traits which we have to, so depending on our objective.
Yes.
Again, depending on the objective, and if it is for resistance or for high yield or for some other traits like quality traits, depending on that, they have to select advanced breeding lines also. And advanced, again, they should have contrasting traits, I feel. We should be able to identify the F1s. If we are not able to identify the F1s, there is no meaning in crossing, sir.
Right.
In that way, if they are crossing too close advanced breeding lines, then it becomes again, what is that, homozygous lines, almost they are homozygous. Maybe Niels development, they may be useful, but not in variety development as it is. They are very closely related. If they are coming from distant crosses, then we can think of, sir, and what characters we want to bring into a single genotype. Depending on that, they can select the advanced breeding lines also.
Right. No, you are right. No, again, you people should interact with Dr. Vasanti. Agree with her or disagree with her. And Raise your queries, if you have any. Professor Muralidharan, did he join or not? No, I think he's not there. Now, I think I'd like to move on to mutation breeding and then interspecific hybridization and farmer participatory breeding. So these are the 3 or 4 more points. Reciprocal differences, natural hybridization, I think this would be enough. 1, 2, 3, 4, 5. 5, 6 points. I would hurriedly try to complete them. I hope you are not tired or bored.
No, sir, no.
Should we continue or you want 5 minutes?
No,
No
sir,
problem,
really
sir. You can continue, sir.
Continue, sir.
Sir, continue, please.
Now, mutation breeding has been, is always quoted as, in case of groundnut, a very successful method of breeding. And VARC has been pioneer in developing varieties, taking recourse to mutation breeding. So, and mutation breeding, what does it do? It creates variation, or rather it releases the variation. It's not creating any new genes. Whatever genes are there already in the genome of that variety, it's breaking their linkage, this and that. So many things are happening, and the variability is released. Some of it is useless, some of it is good. And now if you are able to select the right kind of material, then you are lucky. Because if you don't handle mutation breeding thing, then it can go out of hand very easily. It becomes so large that all your resources will go into this without being sure whether anything will come out of it. And if you look at the varieties released by bark, they are not direct mutant. They have used the mutant again in a conventional breeding. They crossed them with some other material, other variety, then came out with good varieties. So that they recycled the mutant in a regular breeding program to come out with highly successful varieties. I think I am correct in saying that there is no direct mutant released as a variety in groundnut. But mutants have been used in conventional breeding or traditional breeding to develop very good varieties. Please confirm if my statement is correct or it's wrong. There's nobody from bark, right? तोमर साहब,
Yes, sir.
हाँ, आपका क्या कहना है बार के बारे में?
सर अभी सर ज्यादा तो मैं कुछ नहीं कह पाऊंगा क्योंकि सर मैं नया हूं अभी, धीरे धीरे काम सीख रहा
अरे
हूं, कर रहा हूं सर।
कब तक नए रहोगे यार?
हाँ जी सर।
इतना टाइम थोड़ी लगता है। आजकल की बहुएं भी 1 हफ्ते में पुरानी हो जाती हैं।
हाँ जी सर।
नहीं, आई स्टैंड करेक्टेड, but this is my observation. Mutant directly has not been released. They have been released as genetic stock. That is there, but not as a variety. But they have been recycled in a breeding program to develop some very good varieties.
Yes, sir.
Now, wild Arachis species. Now, I know of say two very big programs. Now, new programs are there. In the past, or rather 3 programs. The oldest was Coimbatore. I don't remember the name of two very senior scientists. They were involved in Arachis species. And then North Carolina was there during Dr. Gregory's time. And when ICAR-IIGR started, then we started a lot of work. And there is nothing much which has come out from these 3 programs. And it is long-term plan, you know. It's about wild species. You are not 5 years to 10 years. It may take 15 years, 20 years to come out with something useful. But North Carolina, they shut down the program, except by registering 3 or 4 germplasm lines. Same thing at ICAR-IIGR. We almost closed everything. Coimbatore disappeared long ago. But now, with new tools becoming available, University of Georgia in USA, they have again started a big program. There are two full-time scientists working on wild Arachis species and interspecific hybridization. So let us wait and see what comes out from them. Problem is, like Dr. Nataraj was saying, good resistance is available in wild species for various things. Whatever you will find resistance there. Any pest you take, it is there. But when you start using them in your crossing program, there is dilution. That resistance gets diluted. And there is linkage drag, we all know in wild species. There are several desirable or undesirable traits which also come as a baggage. And how to get rid of them. The moment you try to get rid of them, then the resistance gets diluted. Probably resistance is highly linked with those undesirable traits. So this still remains an issue, but there are examples where we have used interspecific derivatives and recycled them, and we were able to accumulate genes coming from different sources. And maybe they are also different genes. So we were able to improve upon the resistance, and some of the varieties from Dharwad, GPPD4 and others could be a good example. But wild species is a long drawn game. One has to have patience, and it is required to harness the advantage of these genetic resources that are entrapped in them. But it's, as I said, now with new tools, maybe chances of success would be more. But in the past, we have not been highly successful. Anybody would like to make comment on this?
Good morning, sir.
हाँ भाई कहाँ थे? बीकानेर
बस today I am here at Junagadh, sir, due to RAC meeting.
10:30 बजे तक आप मौजूद नहीं थे?
Yes, sir.
10:30 बजे तक आप मौजूद नहीं थे?
हाँ सर, मैं अभी ऑफिस ही यहीं पहुंचे हैं आज इधर।
क्या आज आ रहे हैं अभी बीकानेर से?
हाँ yes today I am arrived, sir.
अच्छा
हाँ, due to RAC meeting. So just I listen half an hour before you.
अच्छा चलिए ठीक है.
Nice lecture, your experience on the groundnut breeding. And I one or two questions
बिल्कुल
on
बिल्कुल
resistance
बिल्कुल
breeding, sir.
बिल्कुल पूछिए.
Sir, I am working on the soil-borne disease, especially on kola rot. We
हाँ,
have one or two, only one and two sources that are not absolutely resistant to kola rot, but it is tolerant or resistant. So I am very getting very difficult to transfer this trait to the cultivated other varieties, because kola rot is a serious problem in light soils. Around 25 to 30% mortality is there, and
yes.
it is very difficult to transfer that gene. It is not easier like transfer gene to foliar diseases. So what I can do for the improving the resistance level, or what is the breeding approach we can do here there, because it is a very serious seedling disease, sir.
नहीं ठीक है. Right.
Yes.
I think important. Okay, very good. Now, what I would suggest to you, because collar rot is a difficult disease
Yes, sir.
and not easy to manage, except of course even management aspect, is not easy. And whatever chemicals are available, they are very expensive. Of course, crop rotation and other things are there. You can contain them, but you cannot eliminate them. So management also remains difficult, and breeding is also there. Now, my first approach would be, because you don't find high level of resistance in any genotype. Whatever level of resistance, maybe these have got 10%, 15% instead of 40% or 50% susceptibility. So
Yes.
we are calling them resistant. So instead of going directly into breeding, one of the breeding objective would be to improve the sources of resistance, to improve the resistance in sources of resistance. So if you have got, how many sources you have? 4, 5, 6?
2 or 3, sir.
2 or 3.
Yes.
So what I would do, I will make the crosses of these in all combination.
So should I make the crosses in all possible combination in resistance genotypes?
Yeah, that's why I said your objective, first objective, improve the resistance,
Improve level of resistance.
level of resistance in sources of resistance,
Okay.
because sources are not perfect.
Yeah.
तो उनका रेजिस्टेंस निकालना, इम्प्रूव करना है. अब वी डोंट नो कि इनके अंदर जो जीन्स हैं रेजिस्टेंस के, दे आर द सेम जीन्स और दे आर डिफरेंट जीन्स.
Yeah.
There are ways we can identify that also. So now make the crosses of these. The 3 parents are there, then go for 3-way cross.
3-way cross.
First F1, any two, then the third parent you bring in. उसका जो प्रोजनी आए, जो 3-वे का जो F2 आए, उसका लार्ज पॉपुलेशन क्रिएट करो. सिलेक्शन नहीं करना है अभी.
ओके.
F2 में मल्टीप्लाई करके F3 में लाओ, उससे भी बड़ा, उससे भी बड़ा हो जाना. अब इसको आप 6 प्लॉट में लगाओ.
ओके.
उसमें देखो, डू यू फाइंड प्लांट्स विच आर बेटर. वो प्लांट जो आपने सिलेक्ट किए उसमें 10, 15, 20, उसमें से फिर देखो संभल के उन प्लांट का इंटरक्रॉस करा दो जितने का करा सकते हो. और फिर उसकी प्रोजनी को फिर आप 6 प्लॉट में ले जाओ. वहां से प्लांट सिलेक्ट करो, फिर उनका प्रोजनी रो करके वो रेजिस्टेंट लाइंस बनाओ नई. ये जो एग्जिस्टिंग वैरायटी है, एग्जिस्टिंग वेराइटीज को नहीं,
Yes.
आप अपनी नई रेजिस्टेंट सोर्सेज बनाइए,
Yes. Yes.
और उनकी यदि परफॉर्मेंस अच्छी है तब उनको यूज करिए आप।
Okay. Okay.
और जो आपके एग्जिस्टिंग सोर्सेज हैं 15-20% वाले, वो डाइल्यूट होते रहेंगे। इसमें
Hmm.
इसमें डाइल्यूशन होगा इसमें, लेकिन उतना नहीं होगा, क्योंकि
Okay. Okay.
आप डिफरेंट जीन्स डिफरेंट सोर्सेज से साथ लेके आ रहे हैं।
Sir, genetic study will help to know the gene genetic variation, resistance.
हाँ,
तो
इसमें आप
आइडेंटिफाइड जो सोर्सेज हैं उनका जेनेटिक स्टडी अगर करें ससेप्टिबल के साथ तो वो हेल्प।
इसमें आपको दूसरी अप्रोच लेना पड़ेगी।
हाँ जी।
मटेरियल तो वही रहेगा,
यस।
आपको क्लासेस बनाने पड़ेंगे
हम्म।
कि भाई 0 to 10% स्कोर 1, 10 to 20, 30-40 स्कोर बनाओगे आप।
हम्म।
तो स्कोर के बेसिस पे आपका होगा। अब पेरेंट जो होगा, आपका पेरेंट विल हैव सम स्कोर।
हम्म।
जब आप ससेप्टेबल वाला कुछ स्कोर होगा, जब उसका वो बनाओगे, क्रॉस बना के आप जब उसको F2 में लाओगे,
यस।
तो वहां आपको देखना है कि भाई F2 में ना स्कोरिंग आप इंडिविजुअल बेसिस पे नहीं कर सकते हो, क्योंकि
हम्म।
अलग अलग है। तो उसमें फिर आपको वेरिएंस निकालना पड़ेगा, कितना वेरिएंस है,
हम्म।
F2 में कितना वेरिएंस है एंड पेरेंट में कितना था। उससे यू कैन वर्क आउट द क्वांटिटेटिव नेचर, एडिटिव जेनेटिक वेरिएंस है या नॉन एडिटिव है, या लाइक दैट, इस तरीके से। एंड उसमें से जो लाइन निकालोगे, उसमें बाद में आप फिर ये क्वालिटेटिव भी एनालिसिस कर सकते हो,
ओके।
लेकिन उसमें टाइम लगेगा, और you have to plan it very properly so that you don't go away. But for the practical, you make three-way cross, and then large F2, F3 population, throw them in sick plot, select the resistant plant, intercross them, again throw them, and select the plant and progeny row them. And compare these lines with your original sources of resistance.
Resistance and susceptible.
If they are better than that, that means the parents are having different genes.
And mutation breeding can help, sir, here.
Mutation is hit and run, trial and hit. It may not.
Okay.
There is no guarantee.
Oh, no guarantee. I am expecting, I am taking some susceptible variety that two-color rot and treat with the gamma rays or radiation, then sow in M2 population in the sick plot.
ठीक है,
Maybe the chance to get the resistance.
नहीं,
One.
ठीक है, that is okay, you can do it. Again, whatever resistant plants you find there, उनको intercross कराओ,
Yes.
फिर
Because
उसको वापस ले जाओ,
हम्म।
और तब उसमें देखो क्या होता है। If you are lucky enough, you will get better resistance.
Yes, 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 yes. Thank you, sir, for sharing your valuable.
Welcome. Anybody else would like to
It
make
is.
comment and suggestion to Narendra?
सर सर रुकम सिंह बोल रहा हूँ सर, तोमर।
हाँ, बोलिए।
Sir, actually, over here I'm trying to go for three-way cross and four-way cross. It is bit easy to identify F1s. लेकिन सर जब F1s आइडेंटिफाई इजी हो जाता है, लेकिन मैं जब थ्री वे क्रॉस और फोर वे क्रॉस के लिए जाता हूँ, तो ट्रू थ्री वे एंड ट्रू फोर वो आइडेंटिफाई करना सर थोड़ा सा मेरे लिए मुश्किल है। एनी आइडियाज रिलेटेड टू हाउ टू without using molecular markers? So even because molecular markers, it is a bit difficult to identify the polymorphic markers in groundnut. So other than using molecular markers, is there any traditional way to identify true three-way cross or true four-way cross or something like that, sir?
भाई प्रॉब्लम ये है ना you have to compare whatever, you know, that hybrid population is there, you have to compare with its parents. One parent is okay, a variety, another is your F1. Now, theoretically, they are supposed to be uniform. Now, the hybrid of these two, you can compare for different traits, physical traits. If you see clear-cut differences, then you can be sure, okay, it is a hybrid. For any reason, if you are not able to discern, then you allow them to grow into next generation and see if it is segregating there or not. Now, it will segregate because F1 was involved. So, that is not the right, that will not tell you anything. It's only F1 label, your minute observation. Or as you said, your markers you can use. But if you have those kind of facilities with you, that's, I don't know, why are you going for 3-way and 4-way?
No, actually, sir, just in the way I'm presently I'm working on back crosses. So true back cross, even identifying true back cross is also a little bit difficult. So somehow, if I go for 3-way or 4 crossing between two F1s to accumulate some genes.
No, you can do one thing there.
Okay, sir.
Select the female parent.
Okay.
Like say, if you are doing back crossing, your F1 is there.
Yes, sir.
That is supposed to carry that resistance gene.
Okay.
Maybe dominant form or recessive form, doesn't matter. The female parent will not have that resistance gene. That is your variety or whatever. Now, if it is this, you make the cross over it. If it is self, and if you try to study the resistance gene in that one, it will not be there if it is self. But if it is genuine F1, the resistance gene would be there. So you can use marker this way and switching over the male and female. Female will self would be female.
Yes, sir.
If that is your standard variety and lacking the resistance gene, then you will easily detect no resistance gene in F1 if it is self. So this can be one of the ways. Now, any other two more things, since okay, yeah, this is now we normally say, yes, please.
Sir, regarding use of advanced breeding lines, sir, one should be very careful. These days, if any advanced breeding line that is in pipeline, if it is used, it should be properly acknowledged, or if there is some danger again, that will be released as it is also. Then breeder will be that risk, sir. That has to be taken care of by all the young breeders. They should follow some ethics also.
That is
Use of
ethics is very important.
Ma'am, just a minute. I meant to advance
madam, 1 minute, and I want let me complete. And if it is from the same center, from the breeder's material only, with the same breeder, then I think there won't be any problem. If it is from some other's material, then you have to think, doubly think.
No, I meant by advanced breeding line developed by our own center, ma'am. I didn't mean.
Okay. In that way also, you should take care that they are
contrasted.
contrasting.
Yeah, ma'am. That's the basic principle. Yeah, ma'am.
And if science is done without ethics, it's not a science. Science is searching for truth. So we have to be very honest in our efforts, maintain the ethnicity of the whole thing that we are doing, because ultimately we are answerable to ourselves. If somebody's help is taken, somebody else's material is utilized, it should be properly acknowledged. And it's a basic courtesy. You don't lose anything. Your stature is only enhanced if you give credit to all those people who have contributed in any product. It's not only groundnut variety or anything. Even in life, this is very important. Unfortunately, there are many instances. I am also sufferer of those, but I never cared because it doesn't matter. I am what I am. If somebody gives me credit, good. If I am not given any credit, good. I am happy. But young people, yes, please be honest to yourself and be honest to your profession. That is important. Now we'll move to reciprocal effect. Normally, reciprocal effect we just lump together. Why kya ho gaya? Why this is different? Oh, reciprocal effect. Now, reciprocal effect, there are two components. One is your maternal effect, and another is, what is the name for that one? Cytoplasmic. So, cytoplasmic, if we have to separate out this in reciprocal effect, these two components, because cytoplasmic effect has bearing in your breeding program. Maternal effect doesn't have that much effect. It's only for one generation, because something developing on the mother plant, and next year the next generation the mother changes, and so its effect also changes. But cytoplasmic effect, particularly in disease resistance breeding, is important. What parent one should use as male or as female. So always keep in mind, cytoplasmic effect is there. Then if it is contributing to enhanced level of resistance, then you need to use that parent as female parent rather than as male parent. And another aspect is natural hybrids. Groundnut is not 100% self-pollinated. There is always some outcrossing because of the honeybees and other insect activities. And in some locations, this can go very high. So you will find lot of natural hybrids. If you look carefully in your material, in your parental stocks, you may find natural hybrids. Don't throw them away. Select them separately, grow them separately, and see if you have got any gold mine there, and then take advantage of that rather than throwing. I had very good advantage of this natural thing. Nature has been very kind to me. Robert 33-1, one groundnut variety. Now, I don't know how many of you remember it. It came, I think, from Kadiri, I think, yeah. And very popular variety at one point of time. And we found natural hybrids in that variety, and from there, I developed 5-6 different varieties. ICGS 11, ICGS 44, and like that, ICGS 37, many of them, and they were all very popular, and they were all different from each other. So the crossing was done by my friends, maybe honeybee, maybe some other insects, and then I was able to select them. So that's why I said, unless you spend 2-3 hours each day in your field, you can't really do much success to your. I'll also like to raise one last point from my side. It's a controversial point and nobody has talked about it. Plot size. of evaluation. Now, initially, I am sure the plot size were decided, by doing different trials, doing different plot sizes and different dimensions also, and seeing, where you find the least variation within the plot, and then coming out with optimum size, taking into consideration, availability of seed and the minimization of variation, this and that. Based on that, but this is generalized across all the locations. The same. If we take our own ICAR-IIGR system, Dr. Natarajan, you should look into this one. There is a standard plot size, a 3-row plot or 5-row plot.
Yes, sir.
Whether the soil is black soil or red soil or your other kinds of soil, the plot size will depend on what is your growing condition. So each location, there is a need to work out the optimum plot size for that location or for that region, rather than having the universal size throughout the country. I'm sure research managers will not like this suggestion. Statistician may also not come out in favor of it, but I feel there's a need to look into it even on experimental basis. And second thing again related to this, not judging the performance based on 1 year only. I think initial evaluation trial is 1 year now or 2 years?
1 year, sir. 1 year, sir.
And then advanced trial is
2 years.
2 years.
Yes,
So initial evaluation we are rejecting also, right?
yes, sir. Rejecting, sir.
That needs to be looked into. My suggestion would be have 2 years in advance, no problem. At least here you should have 2. You cannot reject based on 1 season evaluation. Now, farmer participatory issue was also raised by Dr. Reddy, if I remember. Now, the question is, it has become almost an independent discipline, farmer participatory research and development. Although it is based on your traditional advantage, question is, where do you involve farmers? At what stage you involve farmers? Lot of papers are there. Somebody say right from selection of parents and planning stage all the way through the evaluation. Some say in the end, when you have come out with finished product, and then involve farmer in final selection of the material. So it depends, on obviously you cannot involve farmer in your breeding program right from the beginning. You have better understanding of parental material that you would be using, their scientific basis and other things which farmer may not have. So involving farmer at that stage may not be beneficial in my mind, but there are contrary views to that. But I would suggest when you reach to initial stages, when your material is stabilized, F6 or F7, at that stage, if you have nursery, you can have field days and invite farmers and let them make their selection, and then you use that information and advancing your material. And once you have done that, it's not the farmer alone, you have market also. you have processors also. You have to bring them in also at one or some point. So once the farmers have done it, then next stage would be to bring these people also. And then based on their input, you have to take a decision. And that is how you can narrow down this yield gap as well as this acceptability or non-acceptability of varieties. If farmers are involved, they will have the ownership of the product, and then the product will automatically become popular. Now, yield differences at the research station and yield at farmers field, that lot of factors involved there, and it is nothing to do with variety, but it is basically the management issue, how the things are being managed. Many instances are there where the farmers' yields are higher than research station. So it's a management issue. One has to do a full analysis. What exactly is happening in farmers' field? Are there nutrients lacking, macronutrients, micronutrients, organic matter? So many things are there. Is there any antagonistic effect? So that is the different issue altogether, nothing to do with breeding. I think I'll stop here, Dr. Natraj. Now more questions are there, more discussion is needed, I would be happy.
Thank you, sir.
Excuse me, sir. Hello.
From my side. Hello.
Yes.
Ji, sir.
Shispal from Bikaner, sir.
एक मिनट, let me make a note. So, हाँ बोलिए please.
Sir, one clarification from my side regarding management. At the beginning of your lecture, you told that for ferrous sulfate neutralization, urea is the best, but here for neutralization of ferrous sulfate, citric acid is the best alternate. I think
that was a different thing altogether, you know.
No, sir, I agree with you, but
I am not recommending anything on the management side. I am not expert on it.
Sir,
I was giving example that if you are ferrous sulfate you are applying, then you would be adding something more in that.
Yes,
so that was the idea of management solution, not the management recommendation.
Yes. Sir,
the point was that don't go for breeding solution for each and every problem.
Okay, sir. Sir, my question.
हाँ बोलिए.
Sir, for crossing, the flowering stage means early flower or late flower is contribute or not?
देखिए लेट फ्लावर का मतलब
सीजन लेट सीजन.
तो जो लेट फ्लावर आपके स्पेनिश एंड वेलेंसिया में आएंगे, they would be higher up on the branches, so they would be उनका पैक that will not reach to the ground unless you bend the branch and all that. Now too early flowers, again the plant is still, जब बोलते हैं ना
सर
बचपन से प्लांट जवानी में घुस रहा है, जब फ्लावरिंग आ रही है, इट इज बिकमिंग एडल्ट. तो शुरू का 1 week और सो, दैट इज योर ट्रांजिशन फ्रॉम चाइल्डहुड टू एडल्टहुड. So plant mechanism inside, they are getting adjusted. So you always remove first 1 week flowers.
Okay, sir. Thank you very much.
So that you stimulate more flowering in the end. The late flowering will not help you to develop good pots because there is already so many pots already set in. They will give competition and the last pot will not be able to develop properly.
Ji, sir. Sir, I am also agree with your statement. The rejection of the entry or any entry in IVT first is injustice for that entry, because groundnut is a totally rain-fed crop. If any season face the drought condition, so excellent entry may be dropped. So earlier we are doing 3-year testing in IVT 2 season and AVT in 1 season. I think that system is better than existing one. But you are also the member of the revised system. I don't know.
Don't put blame on me.
No, I am just
Put blame on your ADG and DDG because they dictate what is to be done, not the sign. I'll tell you my experience. When I was working in Malawi, Africa, I used to get seed material from Patancheru hickory set, and it will come through plant quarantine and air freight and all that. I always had problem of poor germination. Although when the material left plant quarantine, it will have more than 90% germination. But very often in many cases, when I'll plant this material in Malawi, germination would be poor. So I would ask these people here at ICAR set, what is happening? Why this issue? They say, sir, at quarantine we test material before it is for germination also. Only the material having whatever limit they had, more than that is passed and sent to you. So something might be happening in transition, in transit. That's the only explanation. Similarly now, you get breeding lines from different centers. First they come to your Junagadh, then now coding is done. Then from there again it is sent by lorry transport or post office, whatever. So seed undergoes lot of stress factors. So first year its performance is not going to be ideal. It should be grown first year, even as a multiplication. Don't record any observation as multiplication.
But it is a 3-tier system, sir, not testing more than 3 times in coordination trial.
The situation should decide, or a babu should decide how many tiers. So there is issue with that.
For sir, natural hybrids, we have to monitor in seed production or in breeding line or where?
Anywhere.
Anywhere.
Natural hybrid, you will be able to detect in uniform material.
Yes.
If it is uniform and you find one odd plant there, then only you will identify whether it's a natural hybrid or mixture, mechanical mixture. If it is a natural hybrid, it will segregate. If it is mixture, it will not segregate.
Yes. Okay, thank you.
Welcome.
Any other questions from the participants?
Sir, my sir.
हाँ बोलिए देशपांडे साहब.
Sir, I have worked on the on-farm research in agronomic research, sir. Agronomic research, in agronomic research, they used to recommend their recommendations by working as on-farm research program is there at Merit. Integrated Farming System Research has a program of on-farm research program. Can we have the on-farm research program for apple groundnut breeding, sir, or crop breeding?
Now listen, it is feasible. It is feasible. You can grow your segregating material in farmer's field, and then you can select there. You can practice selection there.
Yes, sir.
But let me give you few basic tips which also help you in agronomy. Each farmer is a different farmer. Each farmer field is a different field. They are not similar. Please keep this in mind. So whatever you do in one farmer field doesn't mean that same thing will work in another farmer's field.
Yes.
That is why
It
they
is
came out with mother baby trial or whatever name is there. I'll give you one example. In Anantapur, we were doing a lot of management trials also along with breeding. In one farmer field, we collected 30 soil samples from different farmers' fields. On looking at the top, same rocky field, red soil, everything, looked similar. pH was varying from 6 to 8.5.
Yes.
Now, how can I give one recommendation within one village?
It was for site specific research. It can be done there. I was there in agronomic research on-farm research program. They have done like that.
That's what I am saying. Let farmer do the research himself.
In case of, I think that varietal development, for varietal development, can we have this on-farm type of research, sir?
No, you cannot, because you need to have.
In later stage, sir, before releasing variety, in later stage we can have on-farm research.
Yeah, at that point of time you can have, not in the beginning.
Yes, that's I was telling, sir.
At the later stages you can have. In the beginning,
one unit should be there, sir, on-farm research.
That's so many things we need. And
yes, sir.
You can raise with your director research and others, this issue, or in a CARPO meeting. In a CARPO meeting. Because
okay, thank you.
Yes.
Any other questions? Sir, I have one question.
Yes, please.
Regarding the tomato spotted wilt virus resistance studies in research in US. They have grouped the varieties released into different generations. Like first generation, they're all actually field resistant
yes,
varieties. Not there is no tolerance, no immunity there, but only field resistant varieties are there, like Tifton, Georgia varieties. So, is there any kind of such research in India, sir, for any other disease or insects, like any field resistance varieties released?
No, okay. Let me first add, there is very high level of resistance available in wild species. For not only this, but other viruses also, and in compatible group and non-compatible group both. So, but this is a difficult pathway. So there, but again, we also have
उसको मीडिया है वो बताने के लिए कि बुरा है ना
we also have, what was that, PSTV is one, and another virus. What was TSWV known before?
Tobacco streak virus.
No, tobacco streak, yes.
It causes peanut stem necrosis.
Stem necrosis is different.
Yes, sir.
There
bud
also,
necrosis.
Bud necrosis, sorry.
Yes, sir.
So bud necrosis, जो varieties, what we have, largely that's the field resistance. And that plant population is also contributing towards resistance there. Because if population is low, then thrips are attracted, and they transmit, this virus more vigorously. So bud necrosis is one, and then stem necrosis also same thing. But wild species have got resistance, and lot of papers are published. So my friend, anybody else? Let me ask, what is happening at PAU? Jasmeet ji? This TNAU location is which one?
Vrindachalam and Tindivanam, both are joined, sir. Vrindachalam and Tindivanam.
Vrindachalam is there.
Yes, sir. We have Kadri person also.
Has Ajay decided on the final date of the meeting?
Yes, sir. March 18 to 20.
No. This is your ICAR-IIGR meeting.
Yes, sir.
It's a meeting on location.
Meeting on location. Yeah, I think 23rd they might have one meeting, sir. Because chairman is here.
23rd was there.
Yes, sir.
Then I am busy on that day.
Yes, sir.
So I gave him 27, 28, 29, any one of those.
Okay, sir.
So I'm not very sure which one he is finally. 23rd I am not available.
Yes, sir. We'll get back to you, sir, on that. Ajay sir is also traveling to Junagadh. He'll be midway. So once he comes here, I will get back to you. Earlier, chairman suggested to have it on 23rd because he is physically here, but we are not sure, sir.
No. You people can go ahead, no issue. But 23rd I am going somewhere. Okay. I'm invited for some event and I committed to go there. So I'll go there. If you can postpone it to another date, that would be fine. Otherwise, just go ahead.
Right, sir.
But let me know what is the final decision on that.
Sure, sir.
Dahat Saab, Odisha.
सर जलगांव से बात कर रहा हूँ सर।
हाँ बोलिए
सर। हम लोगों ने अभी मैं 1 साल पहले ज्वाइन किया है, तो हम लोगों का जो वैरायटी है सर, जो रूलिंग वैरायटी है फुले भारती और फुले धनी, तो उसमें बीटरनेस थोड़ा है, तो उसको कम करने के लिए हम प्रोसेस कर रहे हैं और हाई ओलिक एसिड के लिए भी कर रहे हैं सर प्रोसेस।
नहीं तो उसमें जो बिटरनेस आई है
जी सर,
उसके पेरेंट्स को देखा, किस पेरेंट का कंट्रीब्यूशन है वो?
सर वो तो नहीं देखा सर मैंने।
देखिए को नहीं, अब जब देखिए आपको पता लग गया कि बिटरनेस है उसमें।
जी सर।
तो आप उसका जो पेरेंटेज है
जी सर,
उसके पेरेंट्स को आप देखिए, उसको स्टडी करिए और उस वाले पेरेंट को इस्तेमाल मत करिए ब्रीडिंग प्रोग्राम में।
जी सर।
क्योंकि यदि आपने फिर गलती से उसको यूज कर लिया,
यस सर,
तो आपका अगला मटेरियल भी खराब निकलेगा।
यस सर।
हमारी 2 या 3 वैरायटीज हाई यील्ड होने के बावजूद भी रिजेक्ट हो गई फार्मर के द्वारा।
यस सर।
वो रिलीज हैं।
यस सर।
एक दोनों रस्ट रेजिस्टेंट वैरायटी यहाँ इंडिया में, एक हेटी में, सेम थिंग। और हमने ये सोचा था कि भाई अरे ग्राउंडनट तेल के लिए जाती है, तेल से क्या फर्क पड़ेगा, इसको नहीं पड़ रहा है। तो नहीं, फिर भी फार्मर्स ने उसको नहीं माना।
सर अभी हम लोगों ने एफएलडी भी लिया था GJG 32 का, तो हमारे इधर में फार्मर्स वो प्रेफर नहीं, उसमें बिटर टेस्ट है सर।
जो भी जहां पे भी ऐसा कोई ऑड करेक्टर नजर आ रहा ना,
यस सर।
इमीडिएटली उसकी पेरेंटेज में जाके,
यस सर।
उसके पेरेंटेज से नहीं समझ में आया तो उनके पेरेंट के पेरेंटेज में,
ओके सर।
वैसा करिए आप, देखिए आपको काफी जानकारी उसमें मिलेगी।
श्योर सर, थैंक यू सर, थैंक यू।
वेलकम।
Sir, for the information of the House and you, we have actually contacted all the ICR institutes which are working on animal diet, cattle diet. So we have contacted them, and this was one of the point raised in the last AGM. It was in the mentioned in the proceedings also. Kadiri Lepakshi has a bitter taste and farmers' acceptance was less. So we want to look into what are the nutritional point of view for the cattle. So we have contacted Goat Institute, Buffalo Cattle Center is there, Sheep Center also, and also Animal Physiology and Nutrition Center is there in Bangalore. We have contacted them, sir. We are in the process of having one like interactive session because we don't have the what you call for before variety release. We are not checking into all those aspects like fodder quality, cake quality. So we need your inputs also on that, sir. We'll probably yes, sir.
We did some work at ICRI set together with ILRI, another CG center, livestock center, and the one variety which we had released for Anantapur, ICGV 1119. Now difficult to remember the numbers.
Yeah, 91114, sir.
91114, right. Now they carried out feeding trial on sheep and goat. There was before that they carried out a trial with general material. There were varietal differences in contribution of fodder quality towards increased meat production and increased milk yield. Milk yield was done with cows and meat was done either sheep or goat. So this 1114 variety fodder was contributing more towards both these traits, meat content and also milk content in cows. And this is a published paper, and they even gave the quantification, how much gain was there compared to standard variety, which probably was TMV2.
Do we get any like a base information like this should be the cutoff value, be higher limit for a phenol content or something like that to check in the varieties before release? Any studies into that, sir? Like what are the upper limit should be?
No, say, as you, I am sure you are aware it. In US, they have taste panel. And in every breeding program, they will have couple of people, 8 to 10 people, they will invite them, and then whatever new material they have come out or they are going to advance further, they will do this taste panel evaluation. And if only qualifies there, then they will promote the material further. Otherwise, actually, once again, old story. This very old variety, large seeded, Jenkins Jumbo. Its name was Jenkins Jumbo. In North Carolina and Virginia, they only do Virginia types, large seeded varieties. And they used this Jenkins Jumbo in their breeding program. This was introduced germplasm there. And finally, they came out with their material. And they found that material was having that bitter taste. So they went back and they traced, the bitterness is coming from Jenkins Jumbo. Then they eliminated that from their breeding program. So one needs to actually, okay, let me narrate one more thing. The very famous peanut breeder from USA in 1900, Carvar. He was a black American, and he was the famous breeder who patented groundnut for oil, this diesel and all those things. He had 200-300 patents in his name. His selection procedure was he will walk in the field and he had a walking stick. He will lift a plant with a stick, pluck a pod, open it, eat one grain. If it is good, he will select. If the taste is poor, he will just spit it out and move forward. So you can do either that in the field itself, or you can do later in the lab.
Thank you, sir. Thank you. And if any questions left, otherwise we'll call off today's
This Mr. Dr. Siddhalingappa.
Hello, sir.
Which station is yours?
Dharwad stations. Dharwad
No, no.
entomologist, sir.
Okay.
Yes.
Yeah. Nobody from your what is another station?
Raichur.
Raichur, yes. Raichur continues to be your center or not?
No, it comes under Raichur University, sir. Agriculture. Raichur University.
No, I know.
Yes.
But nobody is here in the group.
No, sir. No, sir. Today he has an interview. See, CAS interview, promotion interview. Yes, sir. If any other questions for the participants? Otherwise, we can thank Dr. Nigam sir. He's always with us for the groundnut improvement. We are taking his services for many things to improve our groundnut programs, to draft out any policies or to improve our groundnut programs, AICRP program. Even he served in our RAC for ICAR-IIGR Junagadh. So, sir is like always our previous breeders also used to tell that he's a groundnut Pitama, Bhishma Pitama, like that. Thank you, sir. Thank you because it's very enriching to interact with you, and all the participants have got benefit from this one, and we look forward again for our AGM. Probably will be held in Udaipur, and from March 18 to 20, we are expecting a reply from DDG soon. And once it is there, then we'll circulate emails and invitations, sir. Thank you, sir. You're having a lot of travel for the last 2 months, and I'm behind you for getting a date for this interactive session. Thank you for accepting our request, sir. And our director is very happy that this lecture series is going in good this one, sir, flow.
No, this was a very good idea.
Yes, sir.
And it needs to be promoted further.
Yes, sir.
Because
yes, sir.
lot of young people or people who are new to the crop, it takes time to understand about the crop.
Yes, sir.
So they can take benefit from the experience and knowledge of their predecessors. And I'm always very happy to assist, whatever in previous incarnation, IIGR, when it was NRCG, I was one of the midwives. So I've been there with the institute, right, since its birth. So long as I am able to move around, I am still available, would always be available. And I encourage all young people, if they wish to interact me on email or WhatsApp or any, most welcome. They can approach me anytime. They can discuss if they have any issue which they are not able to sort out. I would be more than happy to assist. And Dr. Natraj, you can probably forward them my email ID and mobile number. So if anybody wishes to, and then I can also give them soft copy. Those who are new, Groundnut at a Glance, that booklet that I had written, couple of years ago. And it's very relevant to people who are new to the crop.
Sure, sir. Sure, sir. I will share your email ID with all the group members.
And those who want that Groundnut at a Glance, they can send me their request and I can forward soft copy to them. Right, so I'll take leave here. Thank you everybody for your patient hearing, and please keep on interacting with each other. That is always important, and try to learn from your seniors as much as you can, because that is how the science progresses. So thank you very much to each one of you, and also IIGR for giving me this opportunity to interact with you. And a special thanks to Dr. Natraj. He did not allow me to dose him because I was trying to avoid him, but he was after me all the time. So finally, what was to happen happened today. So thank you very much. Bye.
Thank you, sir. Thank you, sir. Thank you. Have a good day, sir. Thank you.
You too.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay, we are closing the session. Thank you all, and I will share sir's detail in the WhatsApp group. And thank you. We'll see you soon. Thank you, sir.